I will import create cipher IV from the crypto library. I will create a function encrypt symmetric, which will handle symmetric encryption of data. This function accepts two arguments: a key, which is a string representing the encryption key, and a plain text, which is the text to be encrypted. Inside the function, I will create an initialization vector using the random bytes function, which can be imported from the crypto library. Next, I will create a cipher which is equal to the result of calling the create cipher IV function we imported. We need to pass an encryption algorithm to this function as its first argument, and that will be AES256 GCM. We'll pass the encryption key as the second argument to the create cipher IV function, and finally the initialization vector becomes the last argument. I will create a cipher text, which is the result of calling the update method on the cipher. The first argument we pass to this method is the plain text we want to encrypt. The next is the encoding for the data we are encrypting, while the last argument is the encoding of the encrypted output. Then I will call cipher.final with hex again and append it to the cipher text. We will create an auth tag by calling the getAuth method on the cipher and storing the result in a variable tag. Then I will return an object from this function. This object will have an IV property, which is equal to the result of calling the toString method with hex on the initialization vector. It will also have a tag property. It will have a ciphertext property. Let's go ahead and test this out by creating a key using the random bytes function. Then I will create a message with sensitive data. I will call the encrypt symmetric function with the key and the message. Then I will console log the encrypted data, and you can see that it has an IV property, an auth property, and a ciphertext property.